Hello, and welcome to another episode of Boundless Body Radio. I'm your host, Casey Ruff, and today we've got another amazing guest to reintroduce to you now. Dr. Miki Ben-Dor is a returning guest on our show. Be sure to check out Dr. Ben-Dor's first appearance on episode 77, his second appearance on episode 323, and his third appearance on episode 428 of Boundless Body Radio. Dr. Miki Ben-Dor is a paleoanthropologist, researching the association between diet during the Paleolithic and human evolution. He specializes in understanding the period of our evolution known as the Stone Age. He retired from his successful career as an economist at age 52 to pursue his passion for learning about the evolution of our species and got his PhD in archaeology from the University of Tel Aviv. He also has a bachelor's degree in economics and a master's degree in business administration. He has released several studies, including his fantastic and critically acclaimed paper called Man the Fat Hunter. He is the author of the book Live Paleo Style: Overcome the Ancestral-Modern Mismatch to Regain Your Natural Wellbeing, which has recently been translated to English from the original text in Hebrew. You can find Dr. Ben-Dor at his blog at www.paleostyle.com and also on Twitter at Ben-Dor-Miki. Dr. Miki Ben-Dor, what an absolute honor it is to welcome you back to Boundless Body Radio.
Happy to be here again. Yeah.
I told you last time, I'm going to tell you again, you're just one of my favorite people to invite on the show. We always learn something new when you're around. We mentioned that you formally retired at age 52, and you are not slowing down whatsoever with your latest passions. Every time I look up, it seems every few months you've got a new paper, a new study come out, and it's wonderful. I'm just really curious, what is your motivation to continue going on this path and trying to share this message when, presumably you could be on the beach somewhere?
Well, I just have the passion to and the curiosity, uh, and I'm sort of finding a way, and I get encouraged because I find more and more signs that support the initial hypothesis that I had about when I started the Man the Fat Hunter. So I go deeply and deeply into that, and find more and more evidence that could explain the evolution of humans. And to me, it's a good job. It's a I just enjoy the researching and writing about it, talking about it, and I think it's, as a side note, it's also important. It's also important because it supports the diet that that I wouldn't say I recommend, but the diet that I think is healthy for other people to follow, and just the research actually just provide more and more support for that diet that was in our evolutionary. This is what we have. This is the diet that our genes are built to consume. And so I'm thinking I'm doing good, and it's interesting. What more can you ask for?
I love that. Well, last time we had you on the show, I had not finished your book, Live Paleo Style. This time I have finished it. I finished it several times. I really enjoyed listening to it. And one of the things you talk about in your book is our aversion in the current world to things like boredom. And it's one thing that really stuck out to me is as hunter gatherers living in the wild, we would have had an endless amount of things to be learning and exploring. And you even made the point that like a lot of our talk presumably around the fire at the end of the day would be sharing our learnings as everybody would be going out and choosing their own adventure for that day. There was so much autonomy, people could do whatever they wanted, and there was just an endless amount of things that we could learn about the environment around us, weather patterns and animals, and it's just so fascinating. So it makes sense that you do see people retire, and if they don't pick up a new language or learn an instrument or keep going down their passions or learning something new, they tend to really drop off a cliff as far as their health. Yet you retired several years ago and you're busy and so fascinated by what you're doing. Of course, that's going to be motivating for you to keep going.
Yeah. I'm just lucky in this respect, and it's important that you mentioned that humans knew so much about the environment. It's really more than any PhD will ever know about the ecology of any environment because they actually grew in it and they learned it from, what happened and what they saw. And so they knew every insect and every animal and what that animal does and how this tree grows. They knew thousands and thousands of facts about their environment. And of course, they lived in the environment, so things happened to them. And they were, able to talk to or love to talk about it. So, yeah, they exchanged so that I don't think they were ever bored. And the curiosity really was very important for their survival, to be curious. So this is something that we inherited from them, to be curious.
That's very interesting. I mean, when the pandemic happened and a lot of us, including myself, kind of stopped traveling as much as we used to, I found for me personally, I didn't really, after a while, didn't miss the traveling as much as I thought I would. And every day I prioritize walking and walking around my neighborhood. And I marvel at some of the things that I have instinctually learned about birds and different species of birds and what direction they fly and how many there are and like what times of day they're going to be in certain places. And, I'm just walking around my neighborhood a few hours in a day. It's interesting to marvel what that would have been like to spend your entire life and the things that you would learn all the time would be, orders of magnitude greater than any of us could comprehend at this point.
Absolutely. And it was very useful for them in hunting and in foraging for plants as well. So it was crucial for them to know it. And it was interesting for them too. So yeah, it's, it's something that we should encourage, with our children, curiosity. And of course, we're not living in in the savannah or the jungle, but there is today actually it's maybe possible to get all that information from the internet. The internet is real revolution in that respect. That you can really, if you're curious, you can learn anything. You can learn so much.
Yeah, no, that's such a great point. And again, I love in the book how you talk about the mismatches and how we can take the lessons learned from our evolution and just apply them in our lives. Again, we don't need to live in the savannah to apply some of those lessons in our lives. But again, like I said in the beginning, you have not stopped. You're always publishing research, and I wanted to start by talking about the latest publication that you came out with just a few months ago. I don't have it right in front of me. I was just reviewing it not too long ago. Can you tell us about the study that you just researched and were able to get published?
Right. I will tell you, this is, I think, is one of the most important papers uh, that we published. It was me and my partner, Professor Barkai from Tel Aviv University. And for that, I need to give you a little background in evolutionary theory. Okay, so Darwin presented this theory, and the theory very simply say that there are some pressures, environmental pressures, and animals or plants get adapted to this pressure. So they have to change something, and that something changes either there was already diversity in the species itself, so they select the individuals that fit best the new situation, or we wait until there are some changes in the gene, mutations, and these individuals survive. And that was nice and dandy until quite a while ago, but not many years ago. Some people came and said, well, it doesn't really describe the reality of nature in full. Because, and the external pressure that Darwin was talking about, and most scientists still today think is the main cause of evolution, is, for instance, climate. okay, of volcanism, or some powerful, powers of nature, yeah, that like climate. But other scientists came and said, look, this is just describe very small part of the causes of evolution, because there are a lot of pressures that happened inside the niche. So each animal lives in a physical niche, let's say in a place, okay? And they live with other animals. They affect other animals. Whatever other animals do affect them, affect the plants in their area, etc., etc. So you have in a niche a whole community of living creatures, okay, including trees, plants, animals, that affect each other. And we have to take that into account too. So it was called niche construction theory. And the thing about niche construction theory, the big difference, is that the pressure doesn't come from such large powers that we or the animal that got affected has no reciprocal pressure. So, but in small niches, let's say if you have something happen to one animal, that can affect other animals. The fact that these animals is now less prevalent in the environment may affect other animals. That can affect the initial change. So the change can affect change. So it's reciprocal. And this leads to some type of directionality, because you have processes that sort of feed themselves. Okay, if you have a change in the weather or the climate, and it's a pressure, but whatever the animal do, it won't change the climate. But if you talk about a niche, whatever happened to the animal changes the niche. So there are reciprocal processes, and these processes tend to be to lead to some directionality. Now, when you go to human evolution, there is very strange phenomena, and this is the directionality, for instance, of brain growth. So brain grew from about 2.6 million years until about 2.3 million years. Okay, for 2.3 million years, brain grew continuously. Now, if it was just a result of external pressure, like climate, it doesn't make sense, because the climate, is fluctuating. Yeah, so it should actually lead, whatever climate, let's say the drying up led to the extension of the brain or the growth of the brain, because the landscape became more savanna-like, etc., etc. Okay, so that happens once. Now, why it continued to grow? The climate didn't become even drier and drier and drier for the last 2.3 million years. It becomes, sometimes it was wetter, sometimes it was drier. So there is no directionality in what is called the selecting agent. In other words, the pressure source, okay, the driver. There is no directionality in the climate, so why would there be directionality in the result? In other words, Darwin's classical theory doesn't explain the directionality of human evolution. It's not only the brain size, it's many things. For instance, the shape of stone tools. The size of stone tools went down. Fire became used, there was the use of fire became more and more intensive. The cultures became shorter and shorter. In archaeology, we call the culture, whatever, like a set of tools has a certain shape. And then you see that there's a new set of tools. So you call that a different culture. So the first culture was 1 million years old, and the second culture was 1 million years old, and it was worldwide. Third culture was already 300,000 years old, or lasted for 250, 300,000 years. And the next cultures always lasted for tens of thousands of years and became very fragmented spatially. In other words, in many places, different cultures. So the tendency of cultures to get shorter and fragmented. A lot of changes is like that. They're changing in a direction, and that Darwin's theory cannot explain. So I said, okay, maybe the niche construction explain with our theory. The niche construction can explain what happened, and I found out that's what happened actually, because what we said initially, since man the fat hunter, is that humans, because of the constraint on the consumption of protein, had to consume either carbohydrates or fat to the tune of about 65% of the calories. Now, and we supported with future research, in later research, we supported the fact that we were carnivores. So really it paid us, energetically speaking, to complete it from fat rather than carbohydrates. Well, that necessity to complete it from fat caused us to do three typical or three patterns of behavior. One is to hunt large animals, because large animals have, relatively speaking, more fat, and they maintain more fat during dry periods. Because they can consume low quality forage and they don't need to exploit their fat so much. Also, they don't run away, so they can carry more weight. They don't have to be efficient in running. So these are large animals. The second segment that humans used to exploit are the prime adults. In other words, in a herd, you have the old, you have the young, and you have the middle section, which is the prime adult. And humans have tended to hunt the prime adults, which is crazy from a predator's point of view, because the prime adults are the most experienced and are in the best physical shape. So it's crazy from a predator just to actually pick them up, unless you find out that they have more fat. Because their teeth are mostly gone, and they don't eat that much, and the young need the fat to grow, so they don't accumulate that much fat. So this is the second pattern. The third pattern is that humans used to take bones, or to take the parts that were fatter, and leave parts that had no fat and did not consume them. So it's like wasteful hunting. So you hunt and actually use only 50% of the, compared to other predators, and when they hunt, they use all the animals. Anyway, these three patterns actually reduce the robustness of the population, because large animals take many years to replenish the population because they take many years to grow. Like elephants, for instance, they become sexually mature at something like 16 years or 17 years old.
Oh,
And deer becomes mature, sexually mature after 1 year or 2 years. So they can renew the population. If they have some pressure, they can renew the population quite quickly, but elephants can't. So they are more sensitive to predation, to high level of predation than deer. So that's the first thing. The second is that the prime adults are the population that actually responsible for the new generation, for creating the new generation. And the third is that we just hunt too many. We just hunt more than we need. But we hunt because we need the fat. We don't need that meat, the meat so much. So we hunt more than other predators. So these three things create a pressure on these populations. And what happened is that in the next generation, etc., you find smaller and smaller animals. You find that the large animals get extinct. Now, they may get extinct not just because of the human pressure. Maybe there was also climate stress. But the climate stress was more effective because of the human pressure.
mm.
So this is how the niche construction comes into play, because humans, because of their protein constraint, consume certain segment of the population of the herbivores in the niche. There's a smaller number of herbivores. Then humans go and hunt the smaller number. Okay, and so you have a process that actually show you continuity of pressure. And this explains the continuity in the phenomenon that you see, like brain growth. Because in our case, they have to adjust to hunt smaller animals that run faster. They're a smaller target. So this is how we were able to show in the paper that humans were the driver of the decline in prey size, and the decline in prey size was the driver of brain growth, because we needed to learn how to cope, and we really couldn't run faster ourselves. So we had to develop, for instance, bow and arrow, and that the arrow can run faster after the animal instead of us. So it explains, it puts all the theory that we had already published in the past, but now we were able to put it in the context of a modern evolutionary theory and explain why, and this is almost a consensus, is that humans were the ones that caused the decline or the extinction of large animals. Some people still object to that, but most researchers, I think so. You know, there's no committee that decides what is a consensus or not. So, but it looks to me that nowadays most researchers accept that humans were the ones that caused the extinction. For instance, for the main reason is that whenever they appear, wherever they appeared, large animals disappeared. So, for instance, in America, in Australia, in islands like New Zealand, where humans appear a bit later than usual, than in Europe, for instance, or in Africa. And quite a few years after a few years, you know, it could be thousands of years, but few in terms of, you know, geological terms. uh, large animals started to disappear. So that starts to explain why. Because these people that support the human contribution to extinction don't explain why it was. They just say, oh, humans were smart. Well, if they were smart, they would leave the animals, the large animals, enough of them for the next meal. But they could not because they had to have the fat. So this is how we explained, and this is the last paper that we wrote. So really, it's like, for me, it closes the whole explanation from the beginning, the fat, to now to have a full picture,
Wow.
full theory.
Yeah. Well, that's what I've appreciated about all of your work in the past is that it's so unifying in the way that it explains so many different things where there could be theories over here and different thoughts about how we evolved, but especially in the carnivore paper that you wrote, were you talking about how our bodies adapted, how our shoulders adapted, why our guts are the way they are, why we walk on 2 feet, why our brain size is so big, gestational period, fat cells. I mean, you name it. There's so much information in there, and it all supports the same idea that we were fat hunters. We made big animals go extinct, whether we knew it or not. We clearly didn't because, like you said, if we were smart, we would have just hunted what we needed versus over hunting and make these animals go extinct. But that also forced the brain growth as we needed to hunt smaller and smaller and smaller animals. It just I love how unifying it is across so many different disciplines.
You're right, and by the way, there is no other theory. I mean, you'd expect other people to come up with unifying theories. Well, there isn't any, as far as I know. Somebody will come and tell me that there may be one that I haven't read, but there isn't any. There's one that comes close to it. It's called the variable, something variable. It claims that the weather was so fluctuating that humans became they became better good at evolvability. In other words, they could evolve quicker than before. It doesn't explain, for instance, the appearance of agriculture, because when agriculture arrived, there was no fluctuation of climate, and we published a paper about the Levant, where it's an area that is defined and we can study it very well. There are a lot of archaeological sites, and we showed that there's no association between climate changes and the decline in prey size. None. So something else had to explain. And there's no. The paper before that we published was about the appearance of hunting weapons. Okay, so first of all, the first hunting weapon that we know about is a wooden spear. Okay, spear with a wooden tip. It's the simplest tool that you can think of for hunting. The next one is a spear with a stone tip. And this is not so trivial because you have to stick the tip to the wood. It's the stone, yeah? You have to actually glue the stone to the wood. So it's start to be quite a complicated system. And the next one is atlatl, for instance, where you have a spear thrower. So you have like a piece of wood that you hold in your hand, and it has like a tooth that holds the dart, and because you have a longer hand, so to speak, you have a better range for the dart. And then come the bow and arrow. So you have hunting weapons that evolve Nobody ever explained why it evolved. Why didn't they stayed with the why do we need a complicated system if you have a simple system? You see, complicated systems, they just cost more energy to produce and need larger brain to produce. So why? Nobody ever explained that until we came and we said, look, when brain size decline, you need better, it was adaptation to hunt smaller and smaller animals.
Mm. Wow.
So yes, that explains so many things, and there aren't any other explanations. So, you would think that everybody would jump at it and say, oh, it's good. You have some, organizing theory that we can start, working with. But it's not happening, and it's quite expected. I mean, it took, I don't know if you know the tectonic plate theory, where tectonic plates move, right?
Right.
So this guy Wagner, it's W. He came up with this theory in the 1920s. And he said, look, if you look at Africa and you look at America, you can see that if you move them closer, they actually fit each other. So they separated from one another. In other words, there are tectonic plates that are floating around, and there are movements. And he said, okay, if the tectonic plates move one towards the other, you get mountains. Okay, so this is the Rocky Mountains, for instance, or the Himalayas is actually the Indian continent as Indian plate going into the Asian plate, yeah, and create mountains. If they go at that like this, you have friction and you have volcanic action. If they separate, you have other. So it was a unifying theory. One thing could explain. Oh, the problem was that he was not a geologist. He was a meteorologist. He dealt with climate. Okay, so meteorologist. The guy died in the North Pole trying to save a friend.
Oh, wow.
Yeah, but he managed before that to publish a book. That was in the 1920s. His theory was accepted in the 1960s when they start measuring a certain ridge in the middle in the Pacific, and they saw that the magnetism is changing. And it's known that on Earth, sometimes the magnet will point to the east and south, or sometimes to the north. So now we're in a period where it's pointing to the north. But on a matter of millions of years, you can find periods where it was pointing to the south. Even the last change happened about 780,000 years ago.
Hmm.
So they saw that some parts of the ocean floor are pointing. The magnet is pointing to the north, and some to the south. And actually, it was like a mirror in both sides of the ridge. So actually, they became convinced that there is this movement of tectonic plates getting away one from another. So this is what created this is why you find America and Africa away from each other, because that two tectonic plates that going. Anyway, the thing is that it took 40 years for the geologists to accept the meteorologists unifying theory about their business. In the meantime, they first of all ignored him, and then when they didn't ignore him, they actually convened a special meeting to align against him. In other words, to present all the support against his theory, and in the end accepted it.
Wow.
I don't know if it will take 40 years to accept mine. I have no idea. I have no idea how, we're not in the 1920s now. There's internet and there, but the thing is, what I'm convinced that I have to write a book because the theory appears in papers and it's just too large a picture and complete a picture, and it has to be in one place. I started writing the book, but it's maybe 2 or 3 years away, so it will take time.
Well, I for one am very happy that you're writing another book and hope it gets translated to English, just like Live Paleo Style, because
No, it will be
I'm
written
not
in
sure.
English in the first place. No, it's not in English.
Great. Okay, great. Selfishly, I'm very happy about that. One of the things that you mentioned, I think is really important to understand, and it's what you said about the constraints on protein intake. I think this passes a lot of people by, and I think if you understand this principle, you then get to understand how we're also going to get the rest of our calories. I don't even know. I assume that humans are fairly unique in this type of field where we are constrained on the amount of protein that we can eat. That's my assumption. I'm not sure if that's true or not. So I'll ask you, can you explain what that constraint on protein is? Are we unique in the animal kingdom as far as the amount of protein we can eat, and what those implications mean?
Right. I will tell you, but first of all, I have to talk a little bit about constraints. I just saw a YouTube of some scientist woman. I don't remember her name. We may put it in the show notes. I'll find it and I'll send it to you. And she says that all unifying theories are going around the constraints. In other words, and she gave few examples from physics because she's a physicist. And one of them, which most people will know, is the speed of light. So Einstein theory can explain a lot of things because it recognizes the speed of light is finite. In other words, this is it. You cannot go faster than the speed of light. And then she gave some more sophisticated example that I will not repeat, and I'm able to repeat. Anyway, then I saw that and I said, wow, I also came to this thing because of the constraints. And there are two constraints. One is the energetic constraints. In other words, we are limited in the amount of energy that we can spend. So we just can't do everything. We have to, and whatever causes us to spend too much energy may kill us. Now, if prey size decline and it costs more energy to run after a smaller prey, and we don't find a solution to that, we won't be there. We wouldn't be there. Brain, for instance, large brain costs energy. The brain is the most expensive tissue that you can have, right? So the weight is about 2% of the body weight, and the energy that it spends is about 20% of the energy. So brain is very expensive. So when when it grows, you have to ask yourself, where is the income? Okay, here's the expense, but where is the income? And for instance, I'm asking myself, when I want to expand language, language is a subject of tens of thousands of papers. Why we have language, when we have language, how we handle it, etc., etc. Very few people discuss the energetic aspect of language, because language requires large brain. A large part of the brain deals with language, actually to store the words and to combine them, etc., etc. So it must have had some advantage in providing energy for that expense. Otherwise, it just won't work. Here it happened. It helps that I'm an economist by education. So this is the first constraint. The second constraint is our ability to metabolize protein to energy. There are three sources of energy: fat, sugar, that's glucose, and protein. If you look at the chemical structure of them, fat is carbon and hydrogen. Sugars are carbon, hydrogen, and oxygen. And proteins are carbon, hydrogen, oxygen, and nitrogen. So the body can only, now talking about the cells, can only actually use either fat or glucose. They cannot use protein. So the body, what the body does is remove the nitrogen. So he's left with the sugar, with the glucose. Sorry. So that's called gluconeogenesis. Now this process requires enzymes. It happens in the liver. And once the nitrogen is removed, it has to get rid of, the body has to get rid of it because it's poisonous. So it turns it into urea. This also happens in the liver, and through the kidneys. That's why it's called urination. So you urinate. Now this systems of removing the nitrogen in the first place and getting rid of it are not so developed in us compared to other predators. Why? Other predators have been predators for 30, 40 million years. We came into the scene about 2 million years, 2.5 million years ago. We were not able to adapt for, it's not a short time, but it's too short for us to adapt and become like a cat. Cat can consume, nobody knows what is the maximum that carnivores can consume. But cat, for instance, experiments were made with 70% protein, and it has no problem metabolizing it to energy. So we can say that this constraint, what happened is we became carnivores, but we are newcomers. So we had to deal with that problem of the protein constraint. Now, the only alternative to protein is either fat or glucose, carbohydrates. So whatever they are, like it could be any form of carbohydrates, not any form, but forms that the body can actually handle, not fibers, because fibers are also form of carbohydrate, but it's a form that is too complicated for the what's too tied in together and complicated and the body cannot, so we need bacteria to do that.
Yeah.
But anyway, so the humans dealt with the problem by what nature gave them, and they gave them brain. Primates are using their brain to solve their nutrition problems. So it's known that primates with the most dense diet have the larger brain. The brain of primates is a function of the quality of their diet. And what is quality really is less fiber. There are primates that will eat leaves, and on the other hand, there are primates that will eat fruits. Primates that eat, fruits, of course, have larger brain than primates that eat leaves. So humans, that's how they solve the problem, because we came from primates, so we solve the problem with the brain. And that's why we started hunting large animals and concentrating on the fatter parts and concentrating on the prime adults and using our brains to solve the problem.
Wow.
So this is the brain. This is the story with the protein constraint.
Well, I really appreciate that explanation. That is crystal clear. I really love that. And you and I have talked in the past about humans being omnivores, and certainly that is the case, and we are omnivores. My next question is one more of like practicality. So like we know that as humans, we have figured out how to unlock nutrients and how to disable toxins, in particular in plant foods. We cook, we sprout, we ferment, lots of different ways that we found to unlock, again, the nutrients and also to disable some of the toxins in plants to be able to live. My question is more around, again, like the practicality of that. When I'm in a natural environment, I'm looking around, even at a time at the end of summer, early fall, where we're in the habit of saying, like, this is the time where there's lots of fruit. This is the time where things are growing and are becoming ripe. I just, doesn't matter where I am really in the planet, you don't see that much of things that are edible. Yet, the paleo diet is a good example. What people call the paleo diet includes daily vegetables, daily fruits, daily nuts and seeds. And I'm not arguing that any of these things aren't fine for us. And sure, we can be aware of certain things like oxalates and lectins and phytates and ways to prepare to get that out. But from your study, realistically speaking, how much plant foods would we have been able to access, even if we had all those technologies to be able to deal with it?
That's very difficult to say. And, today you have, for instance, the Hadza in Tanzania that today was measured maybe consuming something like 60% plant material. So there's a baobab fruit, and there are some like potatoes, in the ground. Similar, not potatoes, but something similar in the ground. There's plenty of fiber there, but they sometimes they chew and just spit the fiber out. There is and they have metal containers to boil, Think about boiling something without metal containers or without any containers. Just, it may be possible. Some people say that it's possible to boil a hide, sort of container, and you put the fire and it won't burn the hide because of the water inside. I don't know, maybe. But really, boiling is a little problematic in this kind of situation where you don't have metal. So washing, you can put it in a river and wash it like they did for acorns in California. In natural conditions, I have the same problem as you do. I don't think that they ate that much. Hunter, you see, predators, they are called hypercarnivores by zoologists if they eat 70% or more from meat. So even if they eat 30% plant material, they're still considered hypercarnivores. So, and if you look at the large carnivores, and by large I mean around our weight. So let's say lions, hyenas, wolves, 50, 60, 200 kilos. It's considered large carnivore. Social carnivore, large social carnivores are all hypercarnivores. And it's not by chance. It's by energetic constraints. They have to get the energy from animals. If there were no animals, they would die. Even, let's say, take wolves. Wolves are omnivores. They can feed on berries, and sometimes in the season, they can spend days feeding on berries alone. But if you take away the animals that they hunt, they will die because they are just not built energetically to climb on trees and get fruit. So they are omnivores, but omnivores does not mean flexibility of the diet at all. It has nothing to do with flexibility. Omnivory is just consuming from two trophic levels, either plants or animals. Yeah, most mammals are omnivores. 80% of the mammals in one database that I know are omnivores, but they're not flexible. And I would say they are not flexible. Even, let's say, if you take grizzly bears. Okay, I think these are the ones that eat salmon, yeah? They are, like I can say, even they are 50-50, okay, animal source food, and they are not flexible. If the salmon don't show up, they are in deep shit. They are not flexible. They are, yes, they are eating 50-50, but they're not flexible. So the problem that I have when I'm trying to explain my stuff is that people think that humans were so smart, they were flexible, they could eat anything, anywhere, anytime. And it's impossible. It's just not true. It cannot be. The energetic return on consuming plants is about 1/10 of that of consuming animals. So, and even if it was like there are situations in dry periods, there are no plants. So what do? They are not flexible. We are not flexible. Now, what happens is that people look at hunter-gatherers and they see some of them live in the North Pole. Some of them live in Tanzania and consume 70% plants. And they say, look, humans are flexible. They are not. They are not flexible. Without metal containers, the guys in Tanzania would not be able to live there. They have metal tips for their spears and for their arrows. Yeah, they don't have to spend time collecting stones and trying to, to cut them and to shape them. That's the same that stuff. So they use their neighbors. Most of them speak two languages. That's how involved they are with the neighbors. The herders. Anyway, they see, this flexibility of the humans, the hunter-gatherer, recent hunter-gatherers. But that flexibility is in a place. It's not in time, okay? So when you have in certain period, let's say people hunt elephants, and they use, you can hunt elephant with a wooden tip spear. Why? Because elephants, you don't throw spears at elephant. What happens is that you dig a pit and you wait for the elephant and you cover it with some leaves, and the elephant falls into it. It can't move. Now, the only problem that you have is you have to get him to start to bleed. And as soon as it bleeds, it may take a day, it may take 2 days, but he's going to die. Now, what happens if they disappear? The elephant disappear, and you have to hunt smaller animals with the wooden spear. So this is the alternative. It's not like they had the whole ambit of hunting. So if you talk about evolution, you have to take into account the time aspect. But anyway, it's one of these things that you have to explain.
Well, I appreciate that, and it's so contextual, like you said. And like we're talking about the Hadza, and yes, they can consume more plants, but is that their choice? Are they living on marginalized lands? What kind of technology do they have? Like we mentioned, a metal pot. Most people wouldn't consider that technology, but it absolutely is. And it's like you still hear stories that they're eating tubers, but they're spitting out the fiber because they can't use it, and maybe they don't have heart disease, but there's other ailments and cavities and all these other things that they're getting that is different than other populations. You hear about that all the time. And so I really appreciate that contextual lens, because most of us are used to going to the grocery store to get our food. We're used to seeing all fruits and a bunch of vegetables that are very, very, very recent inventions, essentially, in our evolution, the last 100, 200 years. You don't come across fields of cauliflower and broccoli and Brussels sprouts, all these things. These are things that we've changed and invented from mustard plants and other plants we've learned to cultivate. And so I think people lose that, and again, take the argument that yes, we're omnivore to say we can thrive on both plants and animals, but we do have to specialize, like you say. So I think that's such a good point. And I love in your book how you're not only talking about your studies and what we've discovered about evolution, but in your book, you've got an entire chapter about the things that we can apply. Again, the mismatches and the things that we can learn today. So to close out this episode, maybe you can tell us again what your conclusions have been on not only the things that we should focus on to be consuming, but also even things like the timing of when we should be eating, how frequently we should be eating, using the lessons of our evolution to now help us inform our decisions about how to be healthy.
I always say that I treat the paleo template as a safety template. I don't think that we can get an ideal list of foods that we can and that we should eat. But I think that we can get the safe, grade the safety of foods. Uh, the thing is that we are adapted, some of us are adapted more than others to, for instance, to consume plants. Because, we've been subject to evolution continuously since even after the agricultural revolution. So some of us are more adapted to eat, for instance, wheat. Others are not. Some of us are well adapted to exploit precursor of vitamin A and to turn them to vitamin A that we can use. Others not. Have to get it directly from the animal. The problem is that we don't know. Most of us don't do any genetic testing to find out what we have and what we don't have, or how sensitive we are to all kind of stuff. And even if we did, I don't think that we know enough about which genes are what. Some we do. Some we do. We know the gene for celiac disease, for instance, etc. Some we do, but most I think we don't. So we don't know to what foods we are adapted. We don't know much about the foods themselves, what they contain. We don't know how the commercial entities prepare the food. Do they ferment it? Don't they ferment it? How long they cook it? For instance, very simple thing. Bread used to be raised for 12 hours. That's the baguette. If you take a baguette in France, it has big holes in it because it was raised for 12 hours, fermented basically. And the fermentation is on the gluten. So baguettes have very little, I don't know exactly how little, but less gluten than other breads. So we don't know. We lost that knowledge. See, for instance, Ethiopians, there are some Ethiopian Jews that consume bread that's made of a different cereal called teff. And they ferment the teff for 2 weeks before they actually use it to make the bread.
Wow, 2 weeks.
Now, nobody does it if it's not necessary. They wouldn't do it. So something is wrong with this teff when it's not fermented. Now, but they, in their original communities, knew that you have to ferment the teff for 2 weeks. Nobody asked why, nobody knew why. They just knew that if you don't do that, people get sick. This knowledge is lost when we live in cities. We don't know how sensitive we are, and we don't know what the food actually contains, anti-nutrients that the food contains. So the safest food is meat. Very simple. The safest food that we can have is meat. Fat. So that's it. That's the only thing I can tell you. Is just eat as much meat as you can. The largest component, if you want to be safe. Of course, during the time, most people find out what they are, other things that they're sensitive to, and they don't eat them. That's fine also. So if you find out that you're not sensitive to bread, go ahead and eat bread. I'm not sure if you know, or even if you don't feel it, Whether you're sensitive or not, I'm not sure. But maybe, I don't know. I don't know. Uh, so yeah, people probably can eat potatoes if they cook them properly, or yeah. But I would like to express any opinion about it because I just don't know,
Yeah.
and I don't think anybody knows
Mhm.
to what extent we are adapted to consume, and to what extent the food that we eat actually was fermented or was washed properly, or soaked properly, etc., etc.
Yeah. Wow. Well, I'll keep steak on the menu for tonight, with your permission, if that's okay. Sounds great to me.
Absolutely.
Sounds great to me.
Yeah.
Dr. Ben-Dor, I really so much appreciate our time together and everything that you have learned, and also your style of communicating. Like every good scientist I've ever met, you say what we know. You also are very careful to say what we don't know. Even that last question, you weren't baited into saying like, "Oh, everybody should be carnivore." It's like, no, I don't know. I just know that this food is safe. There may be individual variances. And it's a very scientific answer. And I really appreciate that, and I appreciate your style. And definitely always just appreciate conversations with you. And thank you again for taking the time to do this conversation today. Where would you like people to go to find you and connect with you in your work?
It's probably just now, just in Twitter. I think I've lost my blog somehow. Somebody was storing it for me, and I lost contact with them, and I don't find them anymore. So I
Oh,
don't know
no.
if they actually exist. So yeah, so I think it's just Twitter. Twitter is the only communication
Wow.
that they have. And of course the papers. So yeah, the papers are still there, and the book is still there.
Well, we'll tag all of that. I will be very sad to know that the blog that we mentioned in the introduction is gone. If I can't find it, I'll make sure we remove that from the notes as well. That's too bad.
Okay. Yeah, I think it's gone. I believe it's gone.
Oh no,
Yeah.
that's so sad.
I have to ask him actually whether he knows where it is. He was doing me a favor, and for years, he was keeping it for me.
Oh man.
Uh, and now I'm looking for it and I can't find it.
Oh,
But he's living now abroad, so I have to find him and call
oh
him.
no. Well,
Yeah,
best of luck. I had one of my social media accounts recently taken over, and taken from me, and that caused a very small amount of consternation compared to an entire blog for sure. But it was very inconvenient. So again, I hope you track it down. And like I said, we'll tag everything else in the notes. And like I said, Dr. Ben-Dor, it's always a pleasure to talk to you. So thank you so very much for making the time, and thank you for being on the show today. We really appreciate you.
Okay, thanks. Always a pleasure.
Always a pleasure as well.
Bye. Good
And
night.
this has been another episode of Boundless Body Radio.